got dilations and similarity in coordinate plane. We're starting a new unit today. Okay, this is the largest unit that we'll have all year. Unit 2. It's going to take us several weeks / months to get through. Okay, we're going to be talking about this stuff for the whole time. Today, I want to focus on this. How can you use dilations to draw some figures in a coordinate plane? We're going to apply similarity properties in the coordinate plane. Use the coordinate proof to prove figures are similar. Some key terms here: similar polygons, similar ratio, dilation, and scale factor. All right, here we go. Look at me. Okay. That's an important one to write down. I want you to write down this part right here. You can stop right there. Don't need to go any more further than that. Figures that are similar have the same shape. Okay? Figures that are similar have the same shape. Now, I'm going to let you know that they do not necessarily have the same size. Okay? But we'll talk about that throughout the lesson. Okay? So, check out my examples here. 1 and 2, are those the same shape? Yeah, same shape, same size. No, different size. Similar triangle. Okay, we call it a similar triangle. Look at 1 and 3. Same shape? No, one of them is more of an isosceles triangle, and the other one is a right triangle. It's called a right triangle. Right? Right? So, just because it ain't got the same size doesn't mean that it can't be the same shape. Not too bad. So far, pretty simple, right? So far. So far. 3. Go. Similar polygons. Here's what you need right now. Everything over here on this side. All right. Similar polygons. 2 polygons are similar polygons if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. Yes, ma'am. You're right. Every bit of this right here. Okay. Now, when we say if and only if here in this class, that's like your mathematical vow that you take. Yes, it is. Coach, once upon a time you got married Glorious Day, right? Yes. It was nice, probably. You guys really truthfully guys. The only part you gotta remember about the wedding day is just to repeat whatever the dude says and smile. That's pretty much your only day. That's it. So coach, you got up there and you took your vows, right? Yes, sir. And when you take those vows, that's like something you're telling your wife, you're telling God, you're telling everybody. That's there, right? The whole world, right? Okay, so those vows are something that you're solemn to, I'd say, correct? Yes, sir. That's right. That's an if and only if. When you take this if and only if here in class, that's a mathematical vow. It's a lock solid thing. Okay? It cannot be broken. So, if and only if corresponding angles are congruent and side lengths are proportional, do I have similar polygons? Okay? Say this word with me. Proportion. 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 Got everybody saying proportion. Spread. Say it louder. Good word. Proportion. Small. That's right. That's why I just had to say it right now. Okay. Good. So at least we can say it even if we don't know what it means. Okay. Check it out. Proportional. What's going to end up meaning is that it has what's called a similarity ratio. Similarity ratio is the ratio of the lengths of corresponding sides of 2 similar polygons. Okay, that's the only part you need to write down. Just everything above that line. Okay, so this is how we tell if side lengths are proportional in two different polygons. Hear me? Dig it? Can you dig it? Can you dig it? That was a cool song back then. Great.
Sound like my wife.
Oh, you giving your vows to your wife again? Oh.
That's all
Like
right.
third grade.
Yeah, not real walking that.
That's right. All right, check it out here. Here's the proportion of these two triangles. Okay? And we call it proportional because it has a similarity ratio. Look how A to B is 3. Look how B to F is 6. Y'all see that? The side length of A to B is 3. The side length of B to F is 6. Look how B to C is 3. And F to E is 6. And then look at the other A to C over E to D. Okay? All right, if I simplified each of these fractions, what would I get here? Oh, that's a big time thing right there, Miss Jada. 3/6 in simplified fraction form. What is it? Yeah, there we go. Tool I give you. Everybody should be using that tool.
I don't have that tool.
Right behind it there. Take it.
Let me get up.
You get Miss Jada. One half, guys. Each of those side lengths has a side ratio that's 1/2. It's similarity ratio in this case because they are the same. Okay? All right? If I had changed this one side to 7, now all of a sudden was that B to F is 7. That's no longer true, correct? See that? It's not similar anymore. Okay? It has to be the exact same proportion or ratio among the three sides. Okay? All right, here we go. Determine, just watch me do this, okay? You don't have to write this down. Determine whether polygons are similar. If so, write the similarity ratio and the similarity statement. Rectangles, ABCD, and EFGH. ABCD and EFG to the H. Well, here's what you need to know about a rectangle. The opposite sides of a rectangle are what? Congruent. 9, this is 6. This is 6, this is 4. Okay. Watch what I do here. A to B, E to F. A to B over E to F. 6 over 4. Okay? Got me? 6 over 4. Guess where we're going next? A, B, C. Good. Okay, I thought you said something else. B to C is what? Oh, yeah, this isn't a trick question. F to G is what? Okay, 9 over 6. And so on and so forth. Okay? I do the same thing with C to D, G to H, D to A, H to E. Guess what I get on all those, guys? What's my similarity ratio here? 3 over 2, correct? 3 over 2. Okay? Here's how that works out. Okay? First off, I got to tell you which ones are congruent. I skipped that part. In a rectangle has 4 right angles. All right angles are 90 degrees. All 90-degree angles are congruent. Okay, know that. Right. Secondly, this is the hard part. This is the nitty-gritty. Okay. You got to set up your ratios for each of the sides. This is the part that takes the most time. Everybody see? Acknowledge that by shaking your head like this. Okay. Good. Now, at the same time, they're patting your head. Now, rub your belly. See, half y'all don't even know what's going on. Cameron, they think that they're going to get participation points for just sitting there. You guys will get extra, okay? Now, pat your belly and rub your head. Me neither. Anyway, all right. At the end, after I get my 3/2 ratio for each of these side lengths, I can tell you that the similarity ratio is 3/2, and we call this a similarity statement. You see how easy a similarity statement is? Rectangle ABCD. Ooh, what's our squiggly line mean? What's this mean? No. Cameron's right. Cameron, what's that? Cameron. What's that? Cameron. What's that? All right, Cameron, what's this, man? Very good. All right, check it out. Equals, congruent, similar. Everybody see the whole deal here, okay? And y'all look at this. What do you notice about the congruent symbol? It has equality and similarity, okay? Yes, we did that on purpose in that. Yes, ma'am. Well, a congruent one is always equal. Similar just means similarity. All right. Here's what today's work's going to focus on. You need to write this down. Okay? You need to write this down. A dilation is a transformation that changes the size of a figure but not its shape. Pre-image and the image are always similar. Scale factor describes how much the figure is enlarged or reduced. For a dilation with a scale factor k, you can find the image of a point by multiplying each coordinate by k such that AB becomes k times A times k times B. Okay. Helpful hint: if the scale factor of the dilation is greater than 1, it is an enlargement. If the scale factor is less than 1, it is a reduction. Keywords you need to have in your notes: enlargement and reduction. Okay? Y'all got me? Don't just say bigger and smaller. Your 4th grade brother can tell me if something's bigger or smaller. You outsmart your 4th grade brother by going home and saying, actually, that's an enlargement. Actually, that's a reduction. Pretend like you do. Okay? Don't just tell me it got bigger. Got bigger. That's great. Use the 10th grade words that we're giving you. They got their 12 up on steroids. Right? Now, rumor has it that I used to teach this way. When I say dilation, what's a little example of that? Which you say, childbirth. That's the exact thing that I used to talk about. Used to, guys, I would come up here and I'd say, all right, guys, when a lady has a baby, okay, what happens? Well, cervix. Dilates. To how much? 10, not 10 inches, son. That would, good Lord have mercy. Poor woman, okay? God didn't make it to 10 inches. He said 10 centimeters is enough, okay? 10 centimeters, right? And so what happens is this: if this is what happens beforehand, then you dilate, 10 centimeters. The baby's in there. Used to, I'd talk about how it's a boy, and we have to go over how we know it's a boy and all sorts of stuff. Okay, but we're not going to do that. All right. Okay, you just going to assume that it's a boy if I say it's a boy. It's a boy. Okay? You don't have to laugh. All right? Just make sure you get down this part. After you're in there. But that's what happened my first year here. I said, what y'all think about when you talk about violations? That's what somebody said. He's like, that's what happened. See, they're already mad. Didn't take long.
It's asterisk. Yes, ma'am. Yes, ma'am. Okay.
All right. Do I get that part down? I'm gonna give it up 30 more seconds. I have to erase this.
Not the last part, not the
Okay,
stop.
so just as an example, let's see here. My
Like picked out or like
scale factor was 2. Say my scale factor was 2. My coordinate point, my A and B are both 6. What is my pre-image going to be?
somebody might have dropped the ball on that one.
Right? My scale factor is 2.
Okay.
That means I'm going to multiply 2 times 6, 2 times 6, 2 times 6. 12. Good. My image will be at 12, 12. Okay? Right? What if my scale factor
I
was
love that.
1/2? What's 1/2 of 6? 3. Okay? 3, 3. What if my scale factor was 1? Cameron, what if my scale factor is 1? My coordinates are 6, 6. What's 6 times 1? What's 6 times 1? Very good, Cameron, because if the scale factor is 1, it won't change, correct? Let's make sure we got this. Cameron, 3 times 1. Cameron, 1 times 1. Cameron, mama times 1. Very good. All right. Now hear me? Anything times 1 is itself. You can say it like that, that easy. Okay? You can go tell your little brother that. That's fine. All right. You don't have to do this. Just watch how this works. Watch it work. Okay? All right. It says draw the border of the photo after dilation of the scale factor of 502. You got a pretty little pony here. Okay? You got a pretty pony. Here's a photo of it. You want to enlarge the border so that everybody can see it in your room. It was an itty bitty 8.5 by 11, and now you want it to be a 16 by 20. Okay? You got it. There you go. Real world for you. All right. So here's what you do. Take each coordinate point, 0, 0, 0, 4, 3, 4, 3, 0. Multiply each coordinate point by your scale factor. It's not incredibly hard, is it? 0 times 5/2. Cameron, what's 0 times 5/2? Good. Ms. Myers, what's 0 times 5/2? Either Myers, what's 0 times 5/2? 0. Okay. What's your mama times 0? 0. Everybody's mama times 0 is 0. No discrimination there. All right, here we go. 4 times 5/2 is 10. Let's see how I'm going to work this out here, okay? All right, then I would just plot the new points. And voila, my itty bitty photo got bigger, okay? My little pony. Okay? All right, here we go. I want y'all to do this. I will give you the coordinates. A is at 0, 0. I want you to tell me what A prime is going to be after the dilation. Okay? Right, here's your scale factor right here. Scale factor is 1/2. B is at 4. B is at 0.4. Give me this part. Now give me B prime. C is at 1, 2, 3, 4, and D is at 3, 0. Okay, y'all take 30 seconds. Do that for me right now. I will call on somebody for the answer. Okay, you multiply Mr. Dansby, Mr. Dansby, Jordan. It's your last time. You hear me? It's your last time. All right, I'll fall asleep in here again. All right, multiply each of the coordinates by your scale factor, and then write out the new coordinates. All right, 30 seconds is up. Myers 2. It's you. What did you get for A? Wrong. You got gum out. I'll keep you out here too. What's 0 times 1/2? Good. I want that hard. What's 0 times 1/2 again? Good. Mike, you'll do B now. What's 0 times 1/2? What is 4 times 1/2? What's that? Well, this is what you've been doing for 30 seconds now. 1/2 times 4. Half of 4. Times 2. Good. Myers 1. Yes, ma'am. What's 3 times 1/2? Perfect. And help Myers 2 out. What's half of 4? Good. What's 3 times 1/2? What's 3 times 1/2? What's half of 3? What's 3 divided by 2? Because it's the same answer every time, should be pretty easy. Good deal? All right. Oh, back to you. What's 0 times 1/2? All right, there we go. All right, guys. That wasn't that bad, was it? Then I could plot these points. What would happen to my figure here? Would it enlarge or reduce? Reduce in size. Very good. Thank you. Thank you. Appreciate it. All right. Shows you the work involved here. And we get to plot our picture again. Okay? All right. We're not going to get to this one today, don't think. I'll show you how to do this here in a little bit. Okay? So that'll be it for today. I will give you guys your grade.